Notice, and this is the typical copyright. We continue with Mathematics Syllabus 2018. As of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus, the contents of the syllabus itself, remains unchanged. The two main planned changes for the CSEC level math exam are: 1, split the exam into 2 parts, and 2, there will no longer be any alternative sections. All sections will be tested with compulsory questions. Schedule of videos. As you already know by now, sections 1, 2, and 3, all 51 of these videos have been published on YouTube in their entirety. Section 4, some of those videos have been published on YouTube in their entirety. Section 5, statistics, 5 of those videos out of 18 have been published in their entirety. Section 6, algebra, 7 of those videos have been published on YouTube in their entirety, 7 out of 22. Section 7, relations, functions, and graph. This is where we are right now. This is the 20th of 26 videos. Section 8, geometry and trigonometry. Hopefully by March 2026, that will be completed. And finally, section 9, vectors and matrices, by April-May 2026. Please note this disclaimer down here. This schedule is just a projection, which is not to be interpreted as a contract with anybody. Going back to section 1, number theory and computation. This is the very first section of the syllabus. I have divided that into 33 videos, and all of those 33 videos have been made available on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. This section over here. Reminder, you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Going back to section 1, some of these videos are even applicable in the primary school, where students themselves can look at the videos, teachers, and also parents, to help student learning. For example, if you consider this blue box up here, you will notice it says here, video 6, add, subtract, multiply, and divide whole numbers. But before you could do that, before children can do that, they have to know about place values. And that comes in an earlier video. And if you look at video 7, add, subtract, multiply, and divide decimals, and then video 8 talks about addition and subtraction of fractions, video 9, multiplication and division of fractions, and so on. This is work that is done in the primary school, some of it as early as in grades 3, but more so in grades 4, 5, and 6. Then we move on to section 2, consumer arithmetic. All 12 of these videos have been published on YouTube in their entirety. Section 3, sets. All 6 of these videos have been published in their entirety on YouTube. Section 4, measurement. Some of these, as you see indicated in yellow here, have been published on YouTube in their entirety. The others are only partially published on YouTube. If you need full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 5, statistics. Some of these have been published on YouTube in their entirety. The others are only partially published on YouTube. Again, please see directions in the description below if you need full access to these videos that are only partially published on YouTube. Section 6, algebra. 7 of these videos have been published on YouTube in their entirety, and the others are only partially published on YouTube. Again, if you need full access to these videos that are only partially published on YouTube, please see directions in the description below. Section 7, relations, functions, and graphs. This is where we are right now. This section consists of 26 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get especially more practice questions. CSEC recommends the following shown at right. These here. From those, I would recommend these last 2 down here, especially since they form a very good 2-volume set of math textbooks that is quite adequate for the current and the future proposed changes in the structure of the CSEC math exam. This is a picture of volume 1, Mathematics, a Complete Course, with CXC questions by Raymond Tulsi. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page for that website looks like. And this is the home page for that website. Note you would have to register first, and subsequent to that, sign in. Again, this is the URL up here. That URL will be in the description of this video below, so you can easily click on it and be redirected to this website. Just another reminder that this formula sheet is provided for CSEC examination papers, math examination papers. This formula sheet you see on the left here. It is included in the syllabus, but just in case you don't have a full copy of the syllabus, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see it a little better, a little closer. I am going to state the obvious here. You do not need to memorize these formulae, as this formula sheet will be provided during the math examinations. And this is the below part of that same formula sheet. And while you do not need to memorize these formulae, you do need to know when and how to use them. So we are here, section 7, relations, functions, and graphs. This is the first page of that section with 5 objectives. And all of those objectives on this page have been completed. This is the next page, going up to objective 9. All of these objectives have been completed. Next page, up to objective 13. All of these objectives on this page have been completed. Just so you know where we are and where we need to get to. This is the next page up to objective 17. All objectives on this page have been completed. And now this is up to objective 20. Please note objectives 18 and 19 have been completed. We are now at objective 20. And then we will still need to go on for the rest of this section, objective 22, and finally up to objective 26. That's where we need to reach for this section. Okay, as I said, we have finished up to objective 19. And these have been published in their entirety from this section so far, including that one there. These others are only partially published on YouTube. We are now here at video 20. When this is finished, it will be published in its entirety. This is an overview of how the videos from this section will and have been published. As I said, we are here, objective 20. Once that is finished, it will be published in its entirety. And then we have 2 more to publish in their entirety and 4 more partially, as you can see here. So let's get back to this. Section 7, objective 20. And it says, draw and use a graph of a quadratic function to identify its features. And some of the features you have to identify are its roots and some other things here that we will look at as we go along, 4 specific things. Now, the roots of an equation. So we have to do that and some other things, as I said. In section 6, when we did algebra, we already met quadratic equations. In this objective, we will review what we did in section 6 and expand on it as it relates to functions. Just to be clear, you already know that if the function f is such that x maps into 3x minus 1, you can compress that as to say f of x is equal to 3x minus 1, and eventually you can replace this f of x with y, so you get y is equal to 3x minus 1, and this is more familiar to us. And the same thing applies for g. But these are linear functions and equations. As the highest index of x is 1 and will always give a straight line graph. There is a 1 here, 3x to the first power, 2x to the first power. So you would always get a linear equation. Now, but if you take the function f such that x is equal to 3x squared, note that, minus 1, we eventually end up with y is equal to 3x squared minus 1. And the same thing goes for g. Now, these are quadratic functions or equations. As the highest index of x is 2, as you could see here, 3x squared, 2x squared, and will give a parabolic shaped graph. The graph of any quadratic equation in the form of y is equal to ax squared plus bx plus c, where a is not 0, is always a U-shaped curve called a parabola. This curve can open upwards if a is greater than 0, or it will open downwards if a is less than 0, with its lowest or highest point being called the vertex, and it is perfectly symmetrical around a central axis. All right, I will explain all of that as we go along. We will now consider 5 examples to illustrate these features, including roots of a quadratic equation. Example 1. Consider the function f such that x maps into x squared minus 4. We have to do a number of things with that function. Firstly, we have to show the defining equation. So you know how to do that by now. You change this f is a function such that x to f of x, and then eventually you change that to y is equal to whatever is on the right hand side. So this is the defining equation. That's the defining equation from this function. Next, we need to prepare 2 columns. The left one with the x values as a domain from -5 to 5, and the right one as the range. So this is what we need to do. X from -5 to 5, or some people would say from 5 to -5. And then we substitute each one of that in this equation here, and we will get the image of that particular element. For example, if you substitute 1 for x in here, you will get that f of x, which is really y, is equal to -3, and so on. So each element of the domain has an image in the range. Put all those images together and you get the range. So that was the second thing we had to do. Now we have to find the roots of the equation. That is, solve it graphically. So we have to plot those points on a graph. To identify the roots of a quadratic equation from its graph, a parabola, we find the x-intercepts, which are the points where the curve crosses the horizontal x-axis, as these x values are the solutions or roots where y is equal to 0. The roots can be 2 distinct points, one repeated point where it just touches the x-axis, or non-existent if the graph never touches the x-axis. So we have to draw the graph and interpret it. But we did this already in algebra. So this is what the graph would look like. Let's see where it cuts the x-axis. Notice this point here, which is -2, and this point here, which is 2. So that would be the roots of this equation. If you were to solve it any other way, that is what you will get. So we just did that. Now, what elements from the domain has or have an image of 5? Remember, we have to talk about domain and image and so on. So, what elements from the domain, the x value, would have an image of 5. That is, 5 is located on the y-axis. So we go to 5 here on the y-axis, draw a line going to the right and to the left, and then we come down here to see where they will meet the x-axis. And you notice we get -3 here, which is that, and +3 here. So the answer to this, what elements from the domain has or have an image of 5? If we were to start on the domain, we will end up at 5. 5 is the image. And so our answer to that is -3 and +3, but we don't write the positive. So that one is finished. Find the image of the element 4 in the domain. So now we are going to begin in the domain and find where that image would be for this function. So we begin at 4. We begin here now in the domain. Go up until you touch the graph and come across here. And we arrive at that point, which is 12. So the answer to this, find the image of the element 4 in the domain. So it is 4 is in the domain. We find the image in the range. So we begin this 4, we locate this 4 on the x-axis, and we find the image on the y-axis. Next, find the maximum or minimum value of the function. Now, using the graph of a quadratic equation, which is a parabola, read off the y-axis value at the lowest point for the minimum of the function. That is, if a is greater than 0, remember it will open upwards. Or take the y-axis value at the highest point for the maximum. Now in this case, when a is less than 0, it will open downwards. So let's see what we have here. This point here is -4. So we are interested in really the range value. We are interested in the y value, not so much the x value. So find the minimum, that's the lowest point to which this graph will go. And we find that we get -4. So we got that. Finally, state the equation of the axis of symmetry of the function. Now, what do we mean by that? The axis of symmetry is an imaginary line that divides a shape, like a parabola or a polygon, into two identical mirror image halves that perfectly overlap when folded. In parabolas, from quadratic equations of the form y is equal to ax squared plus bx plus c, the vertical axis of symmetry is found with the formula x is equal to -b over 2a, which will pass through the vertex. Now remember, in this objective, we don't have to calculate it. We have to derive it looking at the graph. So the lowest point here, this lowest point here, this vertex, what x value does it have? And as you could see, it has an x value of 0. What is the equation of this line? What's the equation of this line? This line. And the answer is x is equal to 0. So state the equation of the axis of symmetry of the function, and that is it. So we have looked at all of those for this one. The defining equation, we have plotted a graph, we have gotten the roots, we have looked at what element from the domain has an image and what find the image of an element from the domain, find the maximum or minimum, and then state the equation of the axis of symmetry, which is y is equal to 0. All of those things we derive from the given function. In parabolas, from the quadratic equation y, remember I'm saying y is equal to ax squared plus bx plus c, the vertical axis of symmetry is found with this formula here, where x is equal to something, which is minus b over 2a, which passes through the vertex. Remember, you don't have to do that for this objective. But if we do it, we find that b is 0 because we don't have any middle term. We don't have any middle term here. B is 0. And then 2 times 1, a is 1. 2 times 1, so you divide 0 by whatever, you are still going to get 0. So x is equal to 0. That is the axis of symmetry that we found down there. But remember, you don't have to do this for this objective. You don't have to calculate it. If you find this video useful and interesting, please like and share. So like and share. You may also consider subscribing to this channel. Example 2. I am going to go slowly with example 2 as I did with example 1, but for the next 3 examples, I will move very fast. And in any case, the 5th one is a little more than what you need to do. Now we are considering this function here, f such that x maps into 4 minus x squared. And we do those same things that we did for example 1. Let's derive the defining equation. So by now you know how to do that. We have done that so many times. Y is equal to 4 minus x squared. That's the defining equation. So we got the defining equation. Then we prepared 2 columns. The left as the domain for x values from -5 to 5, and the right as the range. We begin here at -5, ended up here at +5, and each of those elements from the domain, in turn, we will substitute for x here, and we will get the image for that element. Put all the images together, and you get the range. So we have completed that. Next, we have to find the roots of the equation, that is, solve it graphically. So we have to plot those points on a graph. And as I said, to identify the roots of a quadratic equation from its graph, which is a parabola, find the x-intercepts, which are the points where the curve crosses the horizontal, that is the x-axis, as these x values are the solutions or the roots where y is equal to 0. So this is what we have. We want to find where the graph intercepts the x-axis. Notice this is basically the same function for example 1, except we now make the x squared negative. And so we will get the same intercept here, because now instead of the graph facing upwards, intercepting at that point, instead of the graph facing upwards, intercepting at that point, the graph is now, the line is now facing downwards, and the intercept is the same as in example 1. So the intercepts -2 and 2. Part 4, what elements or elements from the domain has or have an image of -12? So we will come down here to the image axis, which is the y-axis, locate -12, draw a line across, and then from here, draw a line going up to there, see what we get. And on this side, see what we get up here. And we find that over here is -4, and over here is 4. That's that one. Negative 4 and 4. Find the image of the element negative 1 in the domain. So negative 1 is in the domain. What is its image? We go to negative 1, go up there, come across here. What is that? That is 3. So the answer to this is 3. 3. Find the maximum or minimum value of the function, which is really the highest point here on the y-axis, which gives us 4, which is 4. 5, 7, state the equation of the axis of symmetry of the function. So remember what we talked about, the vertex, the turning point here. What is the x value at that point? And the x value is 0. So that this line coming down here, exactly on the y-axis, what is the equation of this line? What is the equation of this line? And the answer is x is equal to 0. So that is the axis of symmetry. So that took care of those questions for example 2. We have answered all of those questions. Example 3. We have this function. It's a little more complicated now. The function f is such that x maps into x squared minus 4x plus 3. So we have to show the defining equation and do some other things with it. So by now you know that that is fairly easy to do. As you see down here. And we ended up with y is equal to x squared minus 4x plus 3. That's the defining equation from this function. Now prepare 2 columns, the left one with the domain for x values from negative 4 to 8, and the right one as a range. So negative 4 to 8, and we got these values here for the image of each of the element in the domain. Next, we want to find the roots of the equation. Solve it graphically. So we have to draw a graph using those points. If you look carefully, the graph cuts the x-axis at that point and also at this point here. So that one over there is 1, and this one over here is 3. So those are the roots of that quadratic equation. If you were to solve it any other way, you would get those answers, 1 and 3. Without changing this graph, we'll continue with it. What elements from the domain has or have an image of 15? So you come to 15 here, draw a horizontal line and come down to see where each end touches the x-axis. And you could see this one over here and that one over there. And so the answers are negative 2, that is this here, negative 2, and 6, this point over on this side. So that was that question. The next question is find the image of the element 8 in the domain. So 8 is in the domain. We want to find the image, which would be in the range. So 8 is on the x-axis, and we want to find its image, which would be on the y-axis. So you come over here to 8, Draw a line going straight up and then come across here. And where do we arrive? We arrive at 35. So the answer to that question is 35. Next, find the maximum or minimum value of the function. So what is the lowest point this graph touches? And as you could see, the lowest point is here, which is -1. And finally, state the equation of the axis of symmetry. In other words, where does the apex fall? What vertical line do we have at the apex, the lowest point? This line here, it comes down here. On the x-axis, what is this point? And we find that x is equal to 2. That's the equation of this line. And that would have answered all of those questions for example 3. Example 4, consider the function f such that x maps into -2x squared minus 4x plus 6. And then we go through those same steps that we were looking at just now. Show the defining equation and prepare these two columns, of one with domain elements and the other one with the range or the image to those elements. And then we have to solve the equation graphically and so on. So by now you know how to do this. You exchange this to f of x is equal to, and then finally you exchange this f of x with y, and we will get this y. So we prepare the columns here. Now I know I said here -4 to 8, but actually that's not what I did. I did -5 to 3, so I could get a reasonable graph so it would look uniform and nice to us. This will look kind of loop-sided. So even though I said -4 to 8, I actually used -5 to 3 when I was preparing the graph and didn't come back and change this. So what do we get? We get this. Notice the graph now looks balanced, symmetric. If I had been using -4 to 8, it wouldn't look as nice as you see here. But if you had to do this, please do it irrespective of looks. So now we have to find the roots of the equation. Where does the graph cut the x-axis? One point here is -3, and the other one over here is +1. So those are the roots of that quadratic equation. -3 and 1. Next, we want to find what elements from the domain has or have an image of -10. So you come down here to -10, draw a horizontal line until the line touches the graph, and then draw 2 vertical lines to touch the x-axis, which would give us this first point over here, and this next one over on that side, which it would be -4 and 2. So that takes care of that. Next, find the image of the element -2 in the domain. So now -2 is a domain element. What image do we get? -2 is on the x-axis. What image do we get on the y-axis? So we go to -2, which is here on the x-axis. We go up, come across, what do we have here? 6. We have 6 here. Now, that there is 5 below. That is 6. So the answer to this is 6. Next, we want to find the maximum or minimum value of the function. Now, in this case, we want to find the maximum, the highest point it would reach, because it is facing downwards. The parabola is facing downwards, not upwards. And so, what is that point on the y-axis? We find that the answer is 8. So the answer to this question here is 8. And finally, state the equation of the axis of symmetry of the function. Now remember, that happens at the apex, the turning point. So it has to occur here, either the highest point or the lowest point. You draw a line through there until you reach the x-axis, and when we reach that, whatever value we have on the x-axis, that will be the equation of this vertical line. So we come here, draw a line coming down. It touches the x-axis at -1. So the axis of symmetry, the line, the plane that divides that graph into two equal halves, is x is equal to -1. Example 5. Most likely, you will not see this for CSEC. This is just for your information, where we take the information we learn and apply it in a new situation. Consider the function. Now we are beginning with y, not x. Y is equal to y squared plus 4y plus 3. You have to show the defining equations and so on. So we will now replace f of y with x. So we get x is equal to y squared plus 4y plus 3. So those are the two columns that we have. But this time, y is the domain and x is the range. So keep that in mind. So we get x is equal to y squared plus 4y plus 3. Now if you plot that on a graph, this is what we get. So remember what we said about the domain and the range. So if y is now the domain, we check to see the points where the graph cuts the domain axis. Previously, we were saying x because x was the domain. Now, it is where the graph cuts the y-axis because y is now the domain. And what are those 2 points? Here, which is -1, and this one here, which is -3. So if you were to solve that equation, those will be your answers. So if you were to solve this quadratic equation, it is a quadratic equation, but not the one we are accustomed to. Instead of x having a square value, y now has a square value. And x is on the left-hand side and y is on the right-hand side. So we kind of reverse the domain and the range. So -1, -3. As I said, you most likely will not see this for CSEC. Next, what elements from the domain has or have an image of 15? So now we go to the image axis, which is the x-axis, which is here. Draw a line, draw a vertical line, and see where that line will intercept the domain axis, which is 2 up there, and which is 2 up there, and down here it is -6. So the answer to this question is 2 and -6. Next question. Find the image of the element -5 in the domain. Now -5 is in the domain, which will be the y-axis. So we go to -5 down here, come across here, here, and then go up and see where we reach on the x-axis. And that is 8. Find the maximum or minimum value of the function. Now remember, with the y-axis, the top from the 0 will be greater and the below will be smaller. Now, but with the x-axis, from the 0, the left will be lower and the right will be higher than 0. So our lowest point is here. So our lowest point is here. What is that point? It is -1. -1. Finally, we need to state the equation of the axis of symmetry of this function. Now, obviously, it will not be x is equal to something. Now it will be y is equal to something. And that will be where that lowest point of that graph falls. And which would be this axis here, which is y is equal to -2. This point here is -2 on the y-axis. As I said, this example 5 may be a little beyond what you would see for CSEC. Nevertheless, it gives you a trend of thought, a pattern of thought. So you could more easily learn the 4 that we did, examples 1 to 4. Those are required for CSEC. So objective 20, draw and use the graph of a quadratic function to identify its features. And we had to talk about roots of equations. We had to derive element of the domain given image. We had to derive image given an element in the domain. We had to find a maximum or minimum value of a function. And then we had to find the equation of the axis of symmetry. We did 4 examples that you need to learn for CSEC, and another example, the 5th one, that most likely you will not meet at CSEC. So that brings us to the end of video 20 based on objective 20 in section 7.